Hello, welcome to this new start for my indie game Perry, where you play as a sad robot on a planet, just doing some stuff, cutting about the gaff, planting some things, finding some stuff, and generally having a good time. Spoiler alert, doesn't end well. Anyway, you're probably wondering why I'm starting the game again, and there are some reasons. I'll go over a few of them here. The big one I'll save to the end, so you guys will stick around. So there are a few things where the game was going in a certain direction that I wasn't entirely happy with. When I was implementing systems, I didn't always finish them fully, so then it caused a lot of headaches and bugs down the line, and part of that was that I didn't have a full idea of what I was trying to make, and I just sort of made it up as I went along. But now I know exactly what this game's going to be, know exactly how I'm going to do it, because I've already fucked it up once, so I can do that again. Bam! Second up was the art style. Now, I tried to make it look kind of Pixar animation style. The problem is that I've got no artistic talent whatsoever. And that meant there was quite a big disconnect between my models and the models that I'd stolen from other people, as well as, the textures for the terrain and that sort of thing. So it all just looked a little bit weh. And you don't want it to look weh, you want it to look whoa! So we're starting again and it's going to look whoa! And then lastly, the structure of the game was very much level, 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 level. And while that might work for some games, I don't think that my game is built for that. I don't think it's the right fit for the story I'm trying to tell and for the experience I want you guys to have. So we're gonna scrap that as well. So let's go from the top. What have I changed? What have we added? Let's have a look. So this is what the old model for Perry looked like. And I like it, but I think it needs to be square. If you're a long-time viewer of the channel, you'll know I like things square. I love me a square. So I've made this, which isn't quite a square. It's sort of a square with, a skirt. So this was the base. I didn't want to deviate from this too much. I didn't want to try and make it look too smooth or too cool. It's a robot, and it's going to be a blocky robot. Then I gave her a bit more structure. So this is Perry's face, or will be. These are some windows so you can see what she's carried around, and this is the panel on the back where you'll see your power and some other things like that. So as you can see, still similar to the old design, but still very square. Then we gave her a face, cute little eyes, well, cute big eyes. That's the secret to cute eyes, guys. Just make them massive. If you don't look like a deer in the headlights, then be the headlights instead. So yeah, now she's got big old eyes and she looks cute. Then I added these indicators on the back, so this will be how much power Perry has, this will be how much boost you've used, this will be what slot of the tank you're looking at, and this will be if Perry can interact with something. So if you don't have that one, I found when making the game first time round, it gets very confusing and very fiddly. So that's just there to say, hey, Perry can do something right now, press the button. Push the button and let me know you better. Then I blundered. I tried to make Perry a bit smooth. I tried to, soften some of the edges a bit so she's still low poly, but so she looks, not so harsh. And I added these little legs. Look at her little legs. Aren't the little legs cute? They're adorable. But this bevel didn't work for me. I didn't like it. It makes her look too toy-like. I want her to be a robot. She's a robot. She's not a toy. So we undo that. We get rid of that. Back to square Perry, because I fucking love squares, alright? Then it's time to give her some colour. So we've coloured in the windows, we've coloured in all these buttons with light up thingies, light up materials, that's the word I was looking for. They look a bit weird right now because they have to be quite bright for them to give any light off at all, I found. But that's fine, it'll look better in the game anyway. So that's the colour scheme. And then we added animations. So, how do I don't like animating, it's the worst thing in the world. How do I find... Nope, that's not it. Bear with. So this first animation is her looking up. So I want you to be able to look up at the sky. Because why not? It's one of those auteur. It's one of those sort of wanky decisions I make to convince myself that I'm I'm an artiste, I'm an auteur, and not just a pretentious wanker. And then her legs move as well, but I can't figure out how to show you that. I'll just show you in game in a bit. Deal? Then here we are in game, and Perry can move around. She will float, hover, and she can fly up, and that's how you get around the gaff. And you can jump, and you can roll, and you can spin, and you hover around. You hover above the ground. How is this achieved, you ask? Well, I will tell you, even if you didn't ask. I'm just assuming you are. I'm recording this well in advance. I don't know if you're asking or not. I hope you are, though. So, this script is for hovering, because it's called hover. That's the script name. So, in here, basically, we have 4 hover points. These are points where we will push off the ground. And these are on Perry's 4 legs. This is all just initialization bits. We don't really care about that. What we do care about is this function here called apply hover force. So first off, we set the force to 0, and then we do a raycast, which means we fire a little laser down. So we take the hover point dot position, which is where this hover point is, and then we send it down minus hover point dot up. That means we send it down from the hover point. And then we calculate a force based on the distance between the point that the raycast hit and the hover point itself. So we know how far away that point is from the ground. Then we clamp that force to a maximum force and we multiply it by strength, and that just means that we will apply more force the closer to the ground we are and less force the further away. But if it exceeds the maximum force, then we don't apply. Then we just cut it off. So it's like she has a maximum power. And then this last line means we add that force at that hover point position. And then just above in the fixed update, we apply that force to each hover point. We loop through all of the points and we calculate that for each of them every frame. Now hovering's all good and well, but what about moving? Well, for that I have a much more complicated script for you. Now, this looks scary, but we can break it down. So, this top bit, all it's saying is get what the player's input is. Player move is if they have pressed forwards or backwards. Player strafe is if they've pressed left or right, and player turn is if they've pressed Q or E, or one of the shoulder buttons on the controller, and that just means that Perry will pivot in place. Then we tell the animator to set movement input to be whatever the player has inputted the movement to be. This will mean that the legs will move in accordance to how much the player is trying to move Perry. Next, we apply force to the player in the direction of their movement. So if we press forwards, they'll move forwards. If we press backwards, they'll move backwards. And we apply that to the rigid body so that it feels physicsy. And then we also apply something called torque, which means that the player will rotate in the direction of the force that's been applied. So they'll go forwards if we press forwards, and they'll rock backwards if we press backwards. And then we do the same for strafing, but we don't apply a force in a direction when we strafe, because the hovering takes care of that for us. If we pivot to the left, then the left hover points will be closer to the ground and they will apply more force, and so the player will slowly move to the left. And then if the player turns, then we use torque as well, because all we're doing there is rotating left or right. We aren't doing any sort of movement. It's just aiming, essentially. Then, that is the movement taken care of, essentially. But Perry is a robot, and robots have batteries. So we need to check how much the player is moving in any given frame and apply that much power use to the battery. So if you're sat still, you won't use much power, but if you're moving around, flying all over the gaff, then you will use some power. So if player move doesn't equal 0, that means that the player is moving. So we can use that to add to the power use. Perry can't just move on the ground, she can also boost, which is sort of like a little bit of a hop or a fly. So if the player presses the boost and we still have boost remaining, then we add a force to Perry going downwards. And then we decrement the boost level so that if we do run out of boost, you can't boost anymore. Then if the player isn't boosting and they have used some boost, so they've not at the max, then we will slowly increment that back up. Then finally we apply the power use to the battery, reset it for the next loop, and then all we need to do then is check if the player is looking up, because if they are, we need to tell the animator to play the look up animation, and if they're not, we tell them to stop playing the animation. And all of that results in a player who can rotate, who can strafe left or right, who can boost into the air, and just have a general good time, I hope. And then to make the animations work, we have a blend tree in here for forward thrust or backward thrust, which just means that her thrusters will angle forwards or backwards depending on which way you're moving. But then also we want to be able to look up at the same time, so we have to have 2 layers of animation so they can play on top of each other. And it doesn't cause any issues because they're completely different parts of the skeleton, so they can happen simultaneously without worry. And so in-game, if we move forwards or backwards, you can see the thrusters moving forwards or back. And then if you press shift, you can look up and not look up. But you can't really see that animation, but I wanted it there anyway. Now for the teaser trailer, I added a very, very basic version of this, which just said, you know, hard-coded numbers, look up, look down, and that was it. And it was quite janky, but it did the job. But for this, I wanted to make it look a bit better, so I spent a little while trying to write up a much better system for it. And I ended up with this script here, which was good. Now, the problem I had with this script was that the time was being reset constantly, because somehow either condition of the if statement was being met every frame, so it effectively just did nothing. And then the other issue is the way that I checked if the player was supposed to be looking up or looking down was by checking if the camera had reached the rotation angle that I set for it. But angles and Unity don't really get along. It's like oil and water. They just they hate it. Or maybe I'm like that with rotations, because they're horrible. They can smell fear, they know where I live, and they hate me. So what would happen was, I would say, hey, is the camera in this position? And the game would say, no, it's actually not at this position. It's at this position. And then I'd say, well, my script's told you to put it in this position. Why is it not in this position? And the game would go, oh, well, it's close enough, isn't it? And then I'd cry. And at that point, I felt very dejected, and I just deleted everything and thought, sod it, I'll use the janky version. And then I realised I could fix it by adding one little variable. A boolean. I bloody love a boolean. You can't go wrong with a boolean. It's all just a boolean good time. I don't think that makes any sense, but I'm keeping it in. So here's the final script, and here's how it works. If the player's pressing lookup and lookup isn't set yet, then we set the lookup angle target to be up. We reset the time counter for the lerp, and we say lookup set is true, because we've just said it, lookup is true. And then we do the opposite. So if the player isn't looking up and lookup is set, then we set the target angle to be down, we reset the lerp counter, and we set lookup set to be false, because we've just set it to not be looking up. And then, if the camera's Euler angles, which is the angles in degrees, not radians, because that matters for some reason, if that angle isn't equal to the lookup angle, then we lerp, or slurp in this case, which is a smooth lerp. We say that we want to take the camera's rotation, and we want to move it up towards the lookup angle. But we want to not affect the Y angle, because that is our rotation angle. So whatever that is, we leave it at that. And then the way a lerp works is it has a step parameter, and that step is a number from 0 to 1. And anywhere between 0 and 1 is somewhere on the scale of the base position and the target position. So if we use the time, and we just increase that time up every frame, then over a second, it's done, because a second has passed, and so it's gone from 0 to 1. Now in our case, we don't want it to be 1 second, because that looks horrible, so it's actually set to be a fraction of that. But that means that we definitely get to the end, and there's no infinite choppy bits. I explained it in this video. Go have a look at this video if you wanted to know more about lerping and cameras and my general hatred for it. And then all we have to do is, if we've reached the target angle, or at least within 0.05 degrees of the angle, then we reset the timer for the next time. So I went to the input actions and I added some bindings for left and right camera movement. I then read in the rotation and debug logged it to check that it was working. You see the number on the right goes between -1 and 1. That means that we are moving left or right. Then we want to get rid of our old janky transform rotation, which just copies the player's rotation. And then we are free. Perry can move around and the camera doesn't rotate. For now. Now it's time to implement our new rotation. Now we have the player's input, and we need to get the player's input into the camera, but we do not want to just translate that directly. Instead, we want to have a separate object that the player can rotate that the camera will then follow. This is because the player's input can be quite sporadic, so instead we make the camera smoothly follow what the player wants it to do. So we need an object that the player can rotate with their input, and then we need to make the camera follow that object smoothly so we don't cause any headaches. And then also I want it to be able to revert to its original position if there's been no input for a certain amount of time. So that way, if you are focused on other things, the camera can reset to a usable position for you. So I made a new cube, I called it camera target, and I put it on Perry's position, and there were no issues whatsoever. So we took the player's input and then we apply it to the quaternions Y value, which is the angle we want it to rotate at. And that should work. And that isn't working. Okay, let's take another look. Okay, well, I know that quaternions can be a bit weird and they have the W axis, so maybe that's what's messing up. Okay, that's broken in a different way. That's interesting. Okay, let's get rid of W. And the problem there was I was using radians, not the Euler angle, which is degrees. So if we change that, that should work. Okay, that's progress. It looks like it's working, but it's going quite quickly. So let's add in a little bit of a speed modifier. So what we can do is we multiply that input by the rotation speed, and then we'll see how that goes. Not well, is the conclusion there. I see what I did. So the rotation input needs to be multiplied separately from the angle. And we have liftoff. We have a cube that slowly rotates in the direction that we want to do. So that's number one done. The player can rotate the object, but next we need to make the camera smoothly follow that object. And that's where it gets tricky. And that's also unfortunately where I have to disappoint you and say that this is going to have to wait for part 2, because God, this video is getting long already, and you must be sick of hearing me talk, because I'm sick of hearing me talk. But as a reward for your patience, I will tell you the main reason I decided to start my indie game again. Now, listen closely, because this is a big one. My hard drive died.